In this video, we're going to go over section 11.1 from our textbook, which is on the law of sines. So the law of sines is going to allow us to solve non-right triangles by establishing a relationship between the side lengths of a triangle and the sines of their opposite angles. So to derive the law of sines here, we're going to start with an acute or obtuse triangle here and construct a perpendicular line from this angle B to this side AC for this acute triangle. And similarly for this obtuse triangle, we're constructing this perpendicular line from this angle B to our line AC here. Now H is going to be the height of this perpendicular. Then notice that C is going to be the hypotenuse of our right triangle ADB. And then A is going to be the hypotenuse of our right triangle B, D, and C. And similarly for the obtuse case here. So we know that sine of this angle A then is going to be the opposite. So this will be H over our hypotenuse C. And then solving for this H, solving for this opposite side, we get that H is equal to C times sine of A. Now similarly, sine of this angle C here is going to be this opposite side over this hypotenuse. And solving for H, we get this. This implies then, if H is equal to this and H is equal to this, then these two must be equal. So this tells us that A times sine of C is going to be equal to C times sine of A. And we get this guy here. So this brings us to the law of sines here. The law of sines says that in any triangle ABC with sides A, B, and C, this holds here. So when using the law of sines to solve a triangle, we often see several different cases. These guys are listed here. For example, for case 1, we'll see one side and two angles are given. So this is abbreviated as SAA or ASA in our textbook. Similarly, if we were given two sides and one angle, but that angle is not included between the two sides, this is known as side-side angle, SSA. So the order of the information given, the side or the angle, is how this naming convention is chosen. And then we also have the last two cases here where we have two sides and the angles included in between the two sides, or if all three sides are known. So this will come up again, but first let's look at this example. So we want to solve this triangle using the law of sines. So we have our angle A here, our side A, our angle C, so this must be our side C, and then we have our angle B and our side B here. So we want to solve the triangle, we want to find the missing information, and it looks like the missing information is this length and this length, as well as this angle here. So we're going to use the law of sines to first find the side length of this C here, because we have the angle C here, and we have another angle B here, as well as the side length of B. So we know from the law of sines that this holds here. And the reason why we're going to use this case is because we have this angle B, and we have, sorry, this is B here, and then we have this side length B here, as well as this angle C. So in this case, there's only one unknown, and that is C. So what we can do is solve for C by first multiplying sine of C on both sides here, so that these guys will cancel. And we're left with C is going to be equal to B times sine of C over sine of B. Alright, so plugging this information in, this B is going to be 4, that side length there. We know our angle C is going to be 15 degrees, and our angle B is 120 degrees. So then plugging this into a calculator, we get that C is going to be roughly 1.2. Alright, so we found one piece of unknown information. The next piece that we want to find, let's try to find this angle A here. Well, we know that the sum of all of the angles in this triangle must be equal to 180. So that's angle A plus angle B plus angle C all need to add up to 180. So if we want to solve for A, this will be 180 minus our angle B minus our angle C. So this tells us A is going to be equal to 180 minus 120 minus 15. So then A must be equal to 45 degrees. All right, and then the last piece of information we want is going to be this length A here. And so again, we'll use the law of sines, and in this case, we'll use this fact here. And this is because now we have this angle A here. We know angle B and side length B, so all we need to do is solve for A and then plug in our known information. We know that A is going to be equal to B times sine of A over sine of B. Solving for A, just like we did in this case when we were solving for our side length C. So plugging in our known information here, we have 4 times sine of 45 over sine of 120. Now, referring to our unit circle, we know that sine of 45 degrees is going to be the square root of 2 over 2, and sine of 120 is going to be the square root of 3 over 2. So what we'll do is we'll simplify this here. Since we have this divided by this is the same thing as this guy multiplied by the reciprocal of this guy here. So we have 4 times square root 2 over 2 times 2 over square root 3. These guys will cancel here, and so we're just left with 4 square root 2 over 3. Sorry, square root of 3. And if we want to rationalize the denominator, then we'll multiply by the square root of 3, the top and bottom here. This will give us 4 times the square root of 6, because the square root of 2 times the square root of 3, we multiply what's under the square root. And then here we would have the square root of 9, which will be equal to 3. So that'll be our final answer here. And so we solved this triangle because we found the 3 unknown values. All right, so in this table here is the list of the possible number of triangles that we can have given certain conditions. So we're not going to go over every single one in this table here, but we'll see in the next example that it is useful to determine the number of possible triangles, which means the number of possible solutions that we can have. So let's look at this example here. We want to solve this triangle using the law of sines, given that we have our angle A is going to be 80.9 degrees, and we have two sides A and B here. So we want to solve the triangle, meaning we also want to find our angles B and C, as well as our side length C. So since we have our angle A here, as well as our side length A and our side length B, we're going to use this fact here to find our angle B, since we have the other 3 pieces of information. So plugging in our known information here, we have 11.1 over sine of 80.9 is going to be equal to 9.8 over sine of B. And we want to find B. Now in this case, what we can do is we can multiply by sine of B on both sides, and then multiply on both sides by the reciprocal of this guy so that they cancel out. Or something a little simpler is that we can just cross multiply. We can multiply 11.1 in sine of B, as well as sine of 80.9 and 9.8. The reason being is we will get 11.1 times sine of B. I don't know what's going on with my pencil here. Let's rewrite that. This is going to be equal to this product here. So 9.8 times sine of 80.9. Now we can easily just divide both sides by 11.1, and we'll get sine of B by itself. All right. Now, if we want to find this angle B, though, we know that we need to take arcsine on both sides of this guy to get B by itself. So we know that angle B is going to be equal to this here. All right, now plugging this into a calculator and rounding, we'll get that B is going to be roughly 60.7 degrees. All right, so we found our second angle here using our law of sines. Now that we have two angles, what we can do is use the fact that the sum of all three of these angles is going to be equal to 180. We can use this information to find our angle C. So getting C alone, we'll take 180 minus 80.9 minus 60.7, and we'll get C is going to be equal to 38.4 degrees. All right, so the last piece of information that we need to find is then going to be our side length C. We'll use the law of sines here and solve for this side length C. Something else to note here is that we could also use the fact that our side length B over sine of B is equal to this, since we do have our side length B and our angle B, so we could use either one. In this case, I'm just using our side length A and our angle A. All right, so solving for C, we're going to multiply by sine of C on both sides so that they'll cancel here. We'll get C is going to be equal to A times sine of C over sine of A. So plugging in our known information, we'll get this here, and then plugging it into our calculator, we'll see that this is going to be roughly equal to 7, rounding to the nearest whole number. All right, so we solved this triangle using the law of sines given this information. Now we just want to make sure that this is the only triangle, this is the only solution here, and we can do so using what we discussed before, this table here. So notice, in this case, actually going back to this table here, notice that we're pretty much just comparing sine of our angle B and then our side lengths A and B here. Well, notice our length A here is going to be greater than our length B. So that's one thing that's true. And we also found that sine of B, if we were to plug this into our calculator, this is going to be approximately equal to 0.87. So with these two pieces of information here, we can see that we fall under this case here. A is going to be greater than B, and then sine of B is going to be in between 0 and 1. In this case, this tells us that there's only one possible triangle. So when you're doing the homework, just keep this in mind if you're asked to find other solutions or if there are other solutions. All right, so let's do this example down here. We have this diagram here which represents the following. We're told that a satellite is directly above the extension of a line between two receiving towers A and B. We know from radio signals that the angle of elevation from tower A, so this angle here, is going to be 88.9 degrees, and the angle of elevation from tower B is going to be 85.7 degrees, so this guy here. Now, if A and B are 698 kilometers apart, we want to figure out how far is the satellite from A. So we want to find out this distance here. So what we're going to do is label this diagram a little bit better and figure out what we need to find. So since this is angle A here, this is going to be side length A. Since this is angle B here, this will be side length B. And we'll call this angle C here, so this will be side length C. All right, now notice we technically have two angles for A here. We have this angle of elevation, and then we have this inside angle of this triangle here. Now, if you remember from previous sections, if I were to call this A1 here, and this angle A2, these angles A2 and A1 are going to be supplementary, so this will be a supplementary angle. This means that the sum of these two angles is going to be 180 degrees. And that makes sense if we were looking at our unit circle and we're starting from 0 and going all the way over to pi. This straight line here would be 180 degrees. So what we can do is we can figure out this angle A2 here using that information. So A2, let me write it this way, A1 plus A2 is going to be equal to 180 degrees. So this means A2 is going to be equal to 180 degrees minus A1. So A1 is going to be 88.9 degrees. So this tells us A2, this angle is going to be 91.1 degrees. Now, another piece of information that we can find is this angle C here. Since we have these two angles, we know that the sum of all three of these angles must be 180 degrees. So this tells us angle C is going to be equal to 180 degrees minus our angle B, which is going to be 85.7 degrees, minus our angle A2, which was 91.1 degrees. Doing this subtraction here, we'll get C is going to be equal to 3.2 degrees. All right. Now, the reason why we wanted to find our angle C here is because we want to use our law of sines to find B. Now, remember our law of sines says that, for example, A over sine A is going to be equal to B over sine B. We want to find this little b here. We do have our angle B, and we do have our angle A. In this case, it would be A2, but we don't have this length A. So what we need to do is use this length C and this angle C here. So since we have both of those pieces of information, we'll use this fact here and find our side length B. So we can do that by multiplying by sine of B on both sides here. We'll get little c times sine of our angle B over sine of C is going to be equal to this side length B here. So, sorry about that. So this will be C times sine of B over sine of C, which is going to be equal to our length C, which is 698 kilometers, times sine of B over sine of C. Now plugging this into our calculator, we get this here. So the distance between our tower A and our satellite here is going to be this. Alright, so the last example we'll look at is the following. We're told that the bearing of a ship from a lighthouse was found to be this here, which is going to be 16 degrees east of north. Now after the ship sailed 5.9 miles south, the new bearing was 30 degrees east of north. What we want to do is find the distance between the ship and the lighthouse at both of these locations. So this diagram here represents just that. This is going to be due north, and this is our starting point of this lighthouse. So we're told that the first bearing is going to be 16 degrees east of north. So if this is north, we're moving in this direction here. We're moving to the east. So the ship is going to start here and move in the east direction, but only at 16 degrees east of north. So that means this angle here is going to be 16 degrees. Now the next bearing says the new bearing is going to be 30 degrees east of north after the ship moves 5.9 miles south. So this means this angle here between north and this new position is going to be 30 degrees. Alright, so let's continue labeling this here. I'll call our starting point A, then our second position can be B, and our last can be C. So this means this side here, this 5.9 miles south is going to be A, this side here is going to be C, and this side here will be B. Alright, so notice that if this is our angle A here, we see that this total angle is going to be 30 degrees. So if we want to find just this angle for angle A here, we'll take 30 and then we'll subtract off this angle here. So this means our angle A is going to be 30 degrees minus 16 degrees, which will be 14 degrees. So that's this first angle here. Now, with this setup, there's actually one other angle that is given just from this information in this diagram here. And in order to determine that, I'm going to introduce a new definition of alternate interior angles. So these angles are formed when a line, so this line here, intersects two parallel lines. Then the angles lie inside the parallel lines here and on opposite sides of the transversal. And the transversal is this line. It's just a line that intersects two parallel lines. So we have these guys are alternate interior angles. And when we have this case, what happens is this angle, which we'll call x here, is going to just be some measure. Is going to be the same measure as this angle here. And then if we were to call this angle y, then the measure of that angle is the same as the measure of this angle. So these are called alternate interior angles. And going back to our diagram here, notice that our due north is going to be one line here, and then our due south here is another line. So we have two parallel lines, and they're being intersected by this line here. So this is our transversal in this case. So this means that this angle here must be the same as this one, and then this angle here must be the same as this one. So this tells us that our angle B will also be 16 degrees. All right, so now we have two angles. We have our angle A, which is 14, and our angle B, which is 16 degrees. With this information, we can easily find angle C, since we know the sum of the degrees in our triangle must be equal to 180 degrees. Subtracting out our two angles, we'll get our other two angles, we'll get that C is going to be 150 degrees. All right, so now we have all three angles in this triangle here. And with this information, along with this side here, we can find the distance between the ship and the lighthouse at each location. Notice the distance between the ship and the lighthouse at this first location is this side C here. And the distance between the lighthouse and our ship at the second location is this side B here. So since we have these two angles, and our angle B and our angle A, we can use our law of sines here to find the two sides B and C. So first, I will use the fact that these guys are equal here. This means that B is going to be equal to A times sine of B all over sine of A. Plugging in our known information, this side A here is going to be 5.9. Our sine of B is going to be sine of 16 degrees. And then our sine of A will be sine of 14 degrees. Now plugging this into our calculator, we'll get that this is approximately 6.7 miles. So this is going to be the distance between the lighthouse and our ship at this second location here. Now, what we can do in this case is we could use the fact that A over sine of A is going to be equal to C over sine of C to solve for C here, since we have our length A and our angle A and our angle C. What we could also do is, since we found our side length B here, we could use this fact. You could use either one, since we have all the pieces of information. I'm going to use the fact that this guy is equal to this guy, using the fact that we just found our B here. So our side length C is going to be equal to B times sine of C over sine of B. Plugging in this information, we get this here. And then we'll plug this into a calculator and we get approximately 12.2 miles in this case. So that means the distance between our lighthouse and our ship at this first location here is going to be 12.2 miles. Alright, so that'll be it for this video.